again, people. Don't worry. After I finish uploading this video, I'm gonna upload the second video. Because I need to make sure I keep that promise. Also, my arm fucking hurts because I picked a scab on it, and it was like a really bad burn scab. I'll be fine, though. Anyway, we all know and love Superman, right? The big S on his chest, the cape fluttering in the vacuum of space, the casual lifting of islands. He's an icon. But he's an icon built on the rule of cool, and not the cold. Hard logic of biology and astrophysics are also a key detail in there. What if we tried to take care of the character? In other words, what if we tried to make him as realistic as possible given the scientific knowledge we currently have today? What if we took the character, an alien from Krypton with fantastic abilities, and built him from the ground up, factoring in actual constraints of biology, a different planetary environment, and the terrifying realities of real-world physics? Today we're not talking about the Man of Steel. We're talking about a plausible, evolved biological entity. So let's design a realistic Superman. And I really do wish I could draw this right now, because I've been drawing for, like, I don't know how many years, but, I mean, people have told me I'm pretty good, so if I had my drawing supplies, then I'd draw him for you guys. Just to add a little bit more context into this. So, any story of a species starts with its environment. If our Superman is an alien, his home planet Krypton can't just be Earth, but with a different sun. For him to truly be unique, Krypton must be fundamentally different. First, let's start with gravity. Superman is incredibly strong, and you may be wondering why. Why is this alien from another planet stronger than humans? Well, it all boils down to the fact that it's because Krypton had a higher gravity than Earth. So his muscles and his bones would be more adaptive to higher gravity. And that would in turn imply that he may or may not have hollow bones. No, not hollow bones. Hollow bones are like birds and shit. I meant stronger bones, thicker bones, you know. So let's take Krypton's gravity seriously. Krypton needs to be a super Earth, a rocky world, with at least 3 to 4 times Earth's gravity. Also, in the original Superman comics, one of my favorite parts is the fact that Superman couldn't fly. He could just jump really fucking high. And that makes more sense than being able to fly, given the fact that he grew up and lived... No, he was born on a world with higher gravity. So it's much more likely that he'd be able to jump really high instead of flying. See, this high-gravity world would shape life in dramatic ways. Plants and animals wouldn't be towering and graceful. They'd be short, sturdy, and incredibly armored. Evolution here is a fight against being crushed. I believe that Kryptonian flora and fauna, realistically, would be lower to the ground, most likely 6-legged animals with thick carapace-like skin. If you don't know, carapace is like the exoskeleton bugs have. You know, plants would be more dense. They'd be like ground-hugging mosses or sturdy shrubs. Second, the sun. A red sun is a classic part of his lore. To have an environment bathed in a crimson sun, Krypton must orbit a red dwarf star, a Class M star. These stars are dimmer, colder, and far more abundant than stars like our sun, the yellow sun. Here's the thing. Red dwarfs don't provide much in the way of high energy, ionizing radiation, the kinds of stuff our body needs to use to produce vitamin D. This is where things get interesting. What if Kryptonian biology adapted not to use that energy but absorb it and utilize the far more abundant low energy infrared sun that they have? This red sun would have a massive output in infrared and visible red wavelengths. And third, the atmosphere. A denser planet usually has a denser atmosphere. Imagine an atmosphere thick with heavy grasses. Fuck. I meant to say gases, not grasses. What the fuck? Anyway, it would have heavy gases, maybe containing significant amounts of krypton and argon, which are some gases on the periodic table. This thick air would provide buoyancy, making larger life possible despite the intense gravity, but it would also block even more high-energy light. This world that shaped our aliens' ancestors would be a place of bone-crushing gravity, faint red light, and a heavy, thick sky. It's not a paradise, it's a crucible. And to survive, life had to get tough. So what would a sentient species evolved from this environment look like? Let's go ahead and meet our realistic Kryptonian. Forget the chiseled human-like muscles. These muscles are designed for 4G gravity. They're incredibly dense, composed of more robust carbon fiber-like microfilaments. Their skeletons are not just bone, but a composite structure possibly enforced with biomineralized carbon, making them more like reinforced concrete than human skeletons. This isn't strength, it's an engineering requirement for existence. Their skin is a major departure. To survive the extreme gravitational forces and potential debris, it would be much thicker and tougher, with a high concentration of biopolymers, and maybe even trace amounts of silicon, giving it a slightly leathery, matte, perhaps slightly pearlescent finish. It's tough, yes, not bulletproof, as we think it would be, but it's incredibly resilient. But the real marvel here is their cellular biology. Remember that faint red sun? See, instead of relying on solely chemical energy like we do, Kryptonian cells would have co-evolved with highly specialized organelles. Let's call it a photoorganelle. While our mitochondria can convert glucose and oxygen, these cells have perfected an incredibly efficient process of absorbing and converting infrared photons, which are ubiquitous in their environment, and directly into chemical energy for the cell. This would make them hyper-efficient, needing less traditional food, but requiring constant exposure to their sun's specific red spectrum light. Holy shit, dude. Why the fuck am I stuttering so much? You guys may not be able to hear it, but I'm stopping myself from stuttering. Holy shit. Anyway, so this isn't just about surviving. This unique energy pathway is the key to everything else. This process is so efficient that their cells can store massive amounts of this chemical energy. When they expose this anatomy to a stronger, higher energy light source, like a G-type yellow star or our sun, things change. Think of it like putting the right fuel in a high-performance engine. A red dwarf is low-octane fuel. Our sun is racing fuel. Exposure to higher energy light doesn't just charge them. It supercharges their entire biology, pushing their pre-existing adaptations into overdrive. Their dense muscles don't just become strong, they become hyper-efficient and immensely powerful. Their already resilient body becomes capable of feats that defy our perception. This isn't magic, this is a biology optimized for one environment, thriving in a radically different one. So if our hero, raised in the crucible of Krypton, comes to Earth and is exposed to our yellow sun, what powers does he actually have based on this biology that he has? Alright, number 1, we got immense strength and the caveats that they might have with them. Kryptonian muscles are designed for 4G gravity and are hypercharged by a yellow sun. Their power output would be beyond anything on Earth. Could he lift a battleship? Yes. But physics creates a problem, which is structural integrity. If he lifts a massive object from just one point, the object itself would likely crumble under its own weight. To lift a battleship, he wouldn't be lifting the ship, he'd be lifting the section of the hull he was holding, which would rip right off. A realistic Superman couldn't just lift an island. He'd have to find a way to distribute his power across the entire structure, which brings us into a possible hidden adaptation, but we'll get to that. Obviously, we got the incredible durability, or the bulletproof trait. Remember the density, the composite skeleton, the super tough skin? Yeah, to stop a bullet, skin doesn't need to be hard. It needs to absorb and dissipate the massive energy over a tiny surface area. Their skin is more like advanced non-Newtonian body armor. A high-caliber bullet might not penetrate, but it would hit with all its kinetic energy. It would bruise, crack, and certainly knock him down. Bulletproof doesn't mean unaffected. It means he can survive it. This durability extends to extreme temperatures, vacuums, and immense pressures. His body is built to handle the compression of high gravity. Earth is, for him, a very easy place to be. Now, he would also have enhanced senses. His Kryptonian cells are hyperreceptive to infrared and other wavelengths to maximize energy absorption. On Earth, this would make his vision extraordinarily acute. He might not have X-ray vision, a power that defies physics as we know it, but he would have vastly expanded perception into the infrared and ultraviolet spectrums, allowing him to see in total darkness, detect heat signatures through walls, and perhaps even see microscopic details our eyes miss. Similarly, his dense internal structures and highly developed nervous system could amplify sound waves, giving him hyperacute hearing. Not hearing people on the other side of the planet, but hearing a heartbeat from like a mile away. So, what about the powers that don't realistically work for Superman? Well, some of classic Superman's most famous powers present major issues when we stick to strict physics and biology. Now, flight. This is a big one. There is no biological adaptation for a self-powered, logic-defying flight. Animals fly using wings for aerodynamics, gas bladders for buoyancy, or jets for propulsion. A humanoid can't just wish themselves into the air. For a realistic Superman to fly, he would need something else entirely. Maybe a sophisticated anti-gravity suit, or maybe an evolutionary fluke that allows him to manipulate gravity fields. But that's a massive stretch for biology. So our realistic Superman doesn't fly, he leaps, just like the classic Superman did, back in like the 1950s or whatever the fuck. This makes much more sense with muscles optimized for 4G gravity, but Earth's 1G gravity. His leg muscles are incredibly powerful springs. They're controlled with a supersonic jump. It's plausible, though controlling the direction and landing becomes a complex physics puzzle. What about his heat vision? A biological organism projecting two concentrated focused beams of intense visible spectrum energy from their eyes would require a massive amount of power and specialized optics that have no analog in biology. Even the most efficient photo organelle couldn't generate this. So what could be more plausible? I think that it would be a version that expels the buildup of that intense stored solar energy as a rapid burst of electromagnetic radiation centered around the microwave or infrared spectrum, a blast that can superheat metal but isn't a visible red laser. This could work as a defense mechanism but not a precise tool. Now what about his freeze breath? The idea that he exhales air so rapidly that it undergoes Joule-Thomson cooling to cool air from body temperature to freezing, you'd need to have incredible pressure differential and massive volume. It wouldn't be ice breath, it's more like supersonic cooling wind. This could flash freeze moisture in the air and potentially slow down a target. But it's less a magic spell and more a controlled atmospheric blast. A very cool power, but one rooted in fluid dynamics. So there you have it. A Superman designed by evolution, biology, and physics. He's not a magical god-man. He's a squat, dense, incredibly resilient extraterrestrial whose unique cells convert low-energy starlight and a metabolism that is supercharged by our yellow sun. He doesn't fly, he leaps. He's not indestructible, just incredibly durable. His senses aren't magic, but a refined extension of his homeworld's environment. This doesn't make him less. If anything, it makes him more profound, because his story is no longer about, look what this god can do. It's about a thinking, feeling being from a harsh world gifted with impossible power by circumstance, and choosing what he wants to do with it. It's about how highly resilient, super capable aliens try to find their own place in a world that is fundamentally fragile to him. It's not, can he stop a bullet? It's, how does he live in a world where everything is bulletproof except the people he wants to protect? This is a story of power that requires not just strength, but an incredible degree of responsibility and self-control. And that, right there, is a hero worth believing in. That's pretty much it. That's all I had, really, today. Alright? See ya. I'm about to start recording the next video right after this one. Also, I'm just now starting to edit this, and I completely forgot to mention that hidden adaptation that I was mentioning earlier when I was talking about him lifting a battleship. So what I'm thinking of for that is, like, in Superman It was in All-Star Superman. He flew into the sun, and his powers got supercharged, but his cells started dying. And as he was flying away from the sun, he was also saving this group of astronauts, and he was extending his own bioelectric field to carry the spaceship away from the sun. That's what I'm thinking for the whole battleship situation, okay? Don't worry, I didn't forget. I don't know how many things I've forgotten, but please don't yell at me. Bye-bye.